Antimatter, the stuff of science fiction, from the antimatter bomb used in Angels and Demons to Star Trek, where they use matter antimatter, antimatter annihilation, propulsion for faster than light travel. But that's all fiction, right? Antimatter is very much real and they are almost identical to their matter counterparts. The only thing different is that they carry the opposite charge and spin. And when antimatter meets matter, they immediately annihilate into energy. So, are antimatter bombs or antimatter powered spaceships far-fetched? Let's see.
Antimatter was one of the most exciting physics discovery of 20th century. And as research on antimatter has increased over the years, it is helping us in understanding how the universe works. Well, like everything, antimatter also need to be made up of something, but they are not made up of particles. That's for sure. So scientists have named them very creatively antiparticles. Why so anti? Well, every particle has an antimatter companion that is fundamentally identical to itself but with the opposite charge. For example, just as an electron has a negative charge, its antiparticles will have the same mass but positive charge. So we call it a positron.
As we said earlier, when a particle and its antiparticles meet, they annihilate each other. What remains is just a burst of light.
They were first predicted by British physicist Paul Dirac when he was trying to combine the two great ideas of early modern physics, relativity and quantum mechanics. Scientists could not grasp the fact that it seemed to predict that particles could have energies lower than even when they were pretty much doing nothing, which seemed a little impossible at the time as it meant that energies could be negative. Dirac, however, accepted that the equation were telling him the particles are really filling a whole sea of lower energies, a sea that had so far been invisible to physicists as according to him they were only looking above the surface. He theorized that all of the normal energy levels that exist are from normal particles. But when a particle jumps up from a lower energy state, it leaves a hole which appears to us a strange mirror image particle. As far-fetched as it sounded, examples of these particles, antiparticles pairs, were soon found. For example, they are produced when cosmic rays hit the Earth's atmosphere. There is even evidence of energy in thunderstorms producing anti-electrons, called positrons. They are also produced in some radioactive decays, a process used in many hospitals in positron emission tomography, which allow precise imaging with human bodies.
And the source doesn't even always need to be that exotic. For example, even bananas produce antimatter. Yes, bananas release one positron, the antimatter equivalent of an electron, about every 75 minutes. This occurs because the bananas contain a small amount of potassium-40, a naturally occurring isotope of potassium. As potassium-40 decays, it occasionally spits out a positron in the process.
Our bodies also contain potassium-40, which means positrons are being emitted from you too. But as antimatter annihilates immediately on contact with matter, so these antimatter particles are very short-lived.
And that's why there is a problem. Physics predicts that matters and antimatter must be created in equal quantities, and that this would have been the case during the Big Bang.
However, that is not what we have observed. It is almost entirely made up of matter. Yes, dark matter also counts. It is also unobservable to us as they don't emit any light or energy. So where did all the antimatter go?
Antimatter should have destroyed all of the matters in the universe right after the Big Bang. None of us should exist, but we do. As far as scientists tell, it's because in the end there was one extra matter particles for every billion matter antimatter pairs. But why? Well, let's just say it's a work in progress.
Experiments have shown that some radioactive decay processes do not produce an equal amount of antiparticles and particles. But it is not enough to explain disparity between amounts of matter and antimatter in the universe. However, a great many mysteries remain. Experiments are also investigating whether gravity affects antimatter in the same way that it affects matter. If these exact symmetries are shown to be broken, it will require a fundamental revision of our ideas about physics, affecting not only particle physics but also our understanding of gravity and relativity.
In this way, antimatter experiments are allowing us to put our understanding of the fundamental workings of the universe to new and exciting tests. Who knows what we will find? So can we make antimatter bombs and spaceships? In theory, yes.
Antimatter, matter annihilation have the potential to release a huge amount of energy. A gram of antimatter could produce an explosion the size of a nuclear bomb. And because just a handful of antimatter can produce a huge amount of power, making it a popular fuel for futuristic vehicles in science fiction. Antimatter rocket propulsion is hypothetically possible. The major limitation is gathering enough antimatter to make it happen. However, humans have produced only a minuscule amount of antimatter.
But humans have created only a tiny amount of antimatter. If all the antimatter ever made by humans were annihilated at once, the energy produced wouldn't even be enough to boil a cup of tea. The problem lies in the efficiency and cost of antimatter production and storage. Making 1 gram of antimatter would require approximately 25 million billion kilowatt hours of energy and cost over $1 billion. There is currently no technology available to mass produce or collect antimatter in the volume needed for this application. However, a small number of researchers have conducted simulation studies on propulsion and storage. One day, if we can figure out a way to create or collect large amount of antimatter, their studies might help antimatter propelled interstellar travel become a reality. Thank you so much for watching this video. If you have any feedback, please let us know in the comment section below, and do not forget to share and subscribe. Bye bye.